The snapshot of a traveling wave is shown in the figure. Here, the wave speed is 2 meters per second. What is the wavelength, frequency, and period of the wave? So, we know that the velocity is related to the wavelength and frequency by this equation. Note that the wavelength times the frequency is equal to the traveling velocity of the wave. So, we don't know any of these yet, but we can easily figure out the wavelength simply by looking at this graph. So, all we need to do is look at the end of the distance between the two troughs, the two crests, or even just between the starting point and the point where it oscillates one time. So, measuring this point right over here. So, I can't really mark the picture, but like where my cursor here is here. That seems to be about 0.5. And our starting point is 0 meters. So at 0.5 meters, it undergoes one full oscillation. So from that, we know that the wavelength is equal to 0.5 meters, simply from looking at the graph. So that's the first part. Now we can figure out the frequency. From this equation, we can say that the frequency is simply equal to the traveling velocity of the wave divided by the wavelength of the wave. So, have that. And then all we need to do is just plug it in. Traveling velocity is 2 meters per second divided by the wavelength. I can't stand that one. It's just a really bad drawing. Divided by the wavelength we calculated earlier of 0.5 meters. And this is simply 4 hertz, where hertz is 1 time per second. So a hertz is simply just 1 oscillation per second. So that's the frequency. 4 hertz. And then now all we need to do is just find the period. So we know that the period is simply the inverse of frequency. So it's simply just 1 divided by the frequency we calculated earlier, 1/4. So the period is simply just 1/4 of a second. So it makes sense you have it 4 times a second, so you complete it at every 1/4 of a second. And this is how you would solve this problem here.